Completed chapter 6, and so on to chapter 7. Also, this video will go out September 18. I did 42 more problems, and I'm up to 1,1227 problems attempted for Anton. And of course, I read the last 3 sections of the book. In this case, and I've already, of course, started reading chapter 7. In this case, I was working on 4, 5, and 6. So it was the best approximation for least squares. So it's just a continuation of the work that was discussed before in here. Oh, I'm sorry. No, it is not. This is the theory for it. And then there's some errors that need to be calculated. Right here, the b minus ax norm. And then there's also the next section is, of course, one more thing is added. ATA is invertible to the big theorem that we've been having section by section. And then there's a mathematical modeling. And for this one, I actually only did one problem, got it partially wrong, but I understood what I needed to do, and I called it quits and moved on. Because it was really just like the previous section, but with different data. So, with data, what you call data. And then the use of Fourier series. For this one, I did do more work, just because I enjoy Fourier series integrals a lot. A lot. So that was the book itself, and of course then worked on the supplementary problems. And I didn't do the last 2, but other than that, I tried all of them. Those are always very useful. So let's go to my notebook. It continues to get a little thicker, right? It gets thicker. So I started reading section 6.4. And then worked through the examples in the book. I always do that. I actually don't just write down what the example is. I actually work it out myself, just to make sure that I understand how to do it. Otherwise, it's just notes from the book. Then I started working on the problems. Fairly predictable for section 6.4. It's all about just taking the A matrix, doing the transpose, multiplying it times the matrix itself, and that sets up your vector, your x vector, and then it equals to the matrix transpose again times your b vector, and you're just gonna reduce those. In some cases, I made many mistakes. This one in particular, apparently 2 plus 2 can equal 2 sometimes. So yeah, I started up on a mistake. And I just kept getting the wrong result until finally I realized. So I was very sloppy in this problem. And I think in some ways that helped me, because it helped me get a little neater with the follow-on problems. So they all work out like that. All the least squares problems work out like that. And also the, not least squares, but not least squares. This section is... Yes, yeah, least squares. I'm sorry. It is least squares. Sorry about that. For some reason, I thought I was still working on QR decomposition, but that was the previous section. My mistake. Yeah, this is where I was. Yeah, minor errors here and there, but otherwise, the least square problems all work out to be fairly similar. Made a mistake here. I took out a 1/84 to simplify all the algebra, but forgot to put in 84 because it's just t, except 3 is equal to t. Yeah, did pretty well in the true and false. Then for the actual numbers section, just read it, and the problems were identical to the last section, so I only tried one that was different, where the function is not a plus bx, but it's a plus b times 1/x, made a mistake. This is wrong, so I had to look at the answer because what I actually did here is correct, but it's correct for a linear fit, not for a 1 over x fit. Then true and false, didn't do as well here. I could have flipped a coin, got only 50% of them right. And then for the Fourier series, that was a lot more straightforward. It's something that I've done before and happened to love. So worked on the problems, made a mistake for one of them. For this one, I should have applied Grant-Schmidt. Did it wrong, so I'll learn from that. Then actually, I went back and I just, even though I had the answer, I worked it out based on the answer just to know, okay, I made a mistake, I got it wrong. But then question 4, which does not have an answer in the book, is identical to 3, so I had to, at least I had a method, correct method to do number 4. And yes, it really helps to have a workbook with answers for this book. Then here, I made a couple of errors with square roots and a division by 2, but after that, everything else was correct. Because of course I was starting off with the correct values to do all these norms, all these dot products, inner products, and then the projection itself. Yeah, and I got this right. So I was like, okay, I'm doing great. And I got the true and false all correct. Then the supplementary problems, a couple of proofs. Forgot to normalize, but I did get it right. And yes, it is plus or minus because it's that vector. You square it, and when you square it, it can be plus or minus to get the same result. This one, I got lazy. I should have been able to figure this out. Made a mistake here. But then a couple of proofs that I think were straightforward. Usually when I put this across, it means that I'm pretty sure I got it right. A proof about complements. I used older theorems, which I think prove it correctly, but the answer book decided to use the projection theorem, which is also correct. And that is the end of chapter 6.